everyone, it's Mrs. Palermo. I am going to go through these 7-5 notes with you. Unfortunately, I can't be in class today because I have a doctor's appointment. So the first thing I'm just going to do is point out some important things about trapezoids. Is what we're covering today. So trapezoids have one set of parallel sides, one and only one. Sorry, my iPad's doing this annoying rotating thing and I can't fix it, so we're just going to have to deal with it. So the parallel sides are called the bases, and then the non-parallel sides are called the legs. So just a little bit of vocabulary. And then in an isosceles triangle, the non-parallel sides are congruent. Or sorry, an isosceles trapezoid. So we're familiar with isosceles triangles. In an isosceles trapezoid, these two non-parallel sides are congruent to each other. Helpful tips for trapezoids in the coordinate plane. To show that a quadrilateral is a trapezoid, we just want to verify that it does have one, really and only one set of parallel sides. So to do that, we use the slopes. And then to verify or to show that a trapezoid is isosceles, we need to show that it has two congruent sides, the non-parallel ones. So we're going to use the distance formula. So I'm going to go through this next example with you. It says, show that ABCD is a trapezoid. So in other words, the definition of a trapezoid is one set of parallel sides. So we want to show that and then decide whether it's isosceles. So just looking at this picture, I think we can tell that if there's a set of parallel sides, it's BC and AD. I think showing those slopes is sufficient. I don't think I need you to show AB and CD, the other two ones. I just want you to show the ones that look parallel. So find those slopes and verify that they're the same. So the slope, we've done it a million times. The slope of AB count, rise, over, run. Oh, sorry, I said the wrong thing. Not AB. We don't think that one's parallel. We want to do the slope of BC. Is one of them that we want the slope of. So count, rise, over, run. It looks like it's down 1 over 3. So it'd be negative 1/3. The side that looks parallel to it is AD. So let's find the slope of that. Count, rise, over, run. Looks like it's down 2 over 6. So it'd be negative 2 over 6, which is negative 1/3. So we just need to say those slopes are the same. So it has that one set of parallel sides. If you want to be extra sure that you're good, verify that the slopes of these are not the same, but they're definitely not. You can tell that by looking at it. Okay, decide whether it's isosceles. So, isosceles. In order to be isosceles, the non-parallel sides need to be congruent. So basically, in this case, that'd be this one and this one. So let's find those distances. So the distance formula again. The distance of AB is going to be the square root of the difference in x values, negative 2 and 0 are 2 apart squared, plus the difference in y values, negative 1 and 3 are 4 apart squared. 2 squared plus 4 squared is 20. I'm not going to figure out what that equals right now because honestly it doesn't matter. We're just trying to see if it's the same as the other one. So then find the distance CD. So CD is going to be the square root of the difference in x values. 4 and 3 are 1 apart squared, plus the difference in y values, negative 3 and what was that, 2. Negative 3 and 2 apart, 5 apart. Those are not the same. So we want to say it's a trapezoid, not isosceles. So I'm going to say it's a non-isosceles trapezoid. All right, the next one is a U-tri that's very similar to this. In fact, it's pretty much exactly the same. So I'm not going to go over that one right now, but the method is the same. The only difference is you have to plot the points yourself here first. Okay, some theorems. The first one is the base angles theorem. If a trapezoid is isosceles, then each pair of base angles is congruent. So like in this trapezoid, A and D are congruent. That's one pair of base angles. And then the other pair of base angles is BC. So remember the bases are the parallel sides. So the angles attached to those, the angle pairs are going to be congruent. The converse is also true. So remember converse, you flip the order. So the original one says if a trapezoid is isosceles, then the base angles are congruent. The other one says it in the other order. So if we have congruent base angles, then we know it's an isosceles trapezoid. So it works both ways. The final theorem here is the isosceles trapezoid diagonals theorem, which tells you that if the trapezoid is isosceles, or if and only if, so it works both ways. If we have a trapezoid and we have congruent diagonals, then we know it's isosceles. Or if you know it's an isosceles trapezoid, then you know that those diagonals are congruent. So there's a note here that's really important that says for any trapezoid, remember consecutive angles between parallel lines are always supplementary, meaning they add to 180. So like these two add to 180, and then these two add to 180. So keep that in mind. So we're going to use that on this next example. So here we have an isosceles trapezoid. I know that because it's a trapezoid, because it has parallel sides, and I know it's isosceles because those are marked. So in an isosceles triangle, we have congruent base angles. So angle D must be congruent to angle A. So angle D has to be 42 degrees. Okay. Also, in any trapezoid, isosceles or not, these two angles are supplementary because they're parallel lines and you have a transversal. So they're like consecutive interior angles. So to get angle B, we're going to take 180 minus 42. 180 minus 42 is 138. Angle C has to be the same as that because it's an isosceles trapezoid, so those are congruent. So that's 138. This next one is not an isosceles trapezoid. It's not marked like it is, and you definitely know it's not because these angles are not the same. In an isosceles trapezoid, they'd have to be the same. So here we're just using the fact that these consecutive angles in any trapezoid, those have to add to 180 because they're an angle pair. So this one, angle D, excuse me, is going to be 180 minus 62, which is 118. And then angle C is going to be 180 minus 31, which is 149. So that's those. Okay, the triangle midsegment theorem says the midsegment, or sorry, I keep saying triangle instead of trapezoid. Trapezoid midsegment theorem says the midsegment of a trapezoid, which is exactly what you would think it is it kind of goes through the middle of the trapezoid. But it's parallel to each base, and its length is 1/2 the sum of the length of its bases. So that's pretty wordy. So just like by definition here, we know that if it's a midsegment, it cuts this side in half, and it cuts this side in half. So it like connects the midpoints, just like a triangle midsegment. And we also know it's parallel. So the theorem tells me that it's parallel. So if it's the midsegment, I know it's parallel to the bases, which are A, B, and C, D. And I also know that it's 1/2 the sum of the length of its bases. So in other words, there's not enough room on that blank, so hold on. I'm going to write it like underneath the blank, I think. So the midsegment here, which is EF, is equal to 1/2 the sum of the length of its bases. So in other words, you take AB plus CD, add the lengths together, and you divide by 2, because it's got to be 1/2 of that. So this is the kind of the key to this theorem. So here we're showing the midsegments of the trapezoids. I know that they're the midsegments because they connect the midpoints. It shows you it bisects those sides. So we're just using this formula. So it's pretty straightforward. You're just plugging into this. So here I know that MN is going to equal 13.5 plus 18.9 and then divided by 2. You just add them together and divide by 2. I am going to type that into a calculator. So 13.5 plus 18.9 and then divided by 2. Oops, hold on, my calculator's not working. 13.5 plus 18.9. I don't know, my calculator's being crazy. Anyway, just type that in a calculator and see what you get. So that's the length of the midsegment. It's got to be in the middle of these two numbers, or in between those two numbers. Otherwise, it doesn't make sense because we're just averaging them. So it should be right in the middle. Here, excuse me, this one, the MN, the midsegment, is going to be 12 plus 28 divided by 2. That one I can easily do in my head. It's going to be 40 divided by 2, which is 20. Again, it should be directly in the middle of those two numbers. So 20 is 8 away from 12, and it's also 8 away from 28. This one's kind of time consuming. So this is one, and then after this we get to kites. But I think I might just kind of talk through this one. I don't know that I'm going to do it all the way through. So it says find the length of midsegment YZ and trapezoid PQRS. So you have to use the distance formula. So you're going to use the distance formula to find the distance of this. And I'll show you that. So that's called, I'm going to call that segment SP. It's going to be the square root. The difference in the x values is 2. Plus the difference in the y values is also 2. So it's going to be the square root of 8. Then you need the other distance. So you need this distance. So you need QR is going to be the square root. The difference in the x values is 6. Plus the difference in the y values. 3 and -3. Those are 6 apart. 6 squared plus 6 squared is 72. Okay. Then you're just using the formula. So you know it's got to be the average of those two. So the mid segment is always going to be those two added together. And then divided by 2. My calculator is being like ultra annoying and it's not letting me type anything. So I'm just going to let you type them in the calculator. Make sure if you're going to type it all at once, it's got to look exactly like that. You might want to do it in more than one step. Like take the square root of 8, write it down. Take the square root of 72, write it down. Add them together and divide by 2. And that's going to give you the length of YZ. I will upload it later with an answer. And then the last thing here is kites and identifying quadrilaterals. So kites, in order to be a kite, it's a special kind of quadrilateral. It has 2 pairs of consecutive congruent sides, but opposite sides are not congruent. So we know that these are congruent, and then these are also congruent. So the opposite sides are not congruent. The kite diagonals theorem says if a quadrilateral is a kite, then its diagonals are perpendicular. So in every single kite, the diagonals are perpendicular. Then this one says, the third one says, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So just this one pair of opposite angles are congruent. Notice there are no proofs on the notes today. I'm pretty sure there's none on your homework either. Proofs are not a big emphasis in this chapter, so I don't know that you need to focus on like memorizing all these names of the theorems and everything, but you need to know all these properties. So however you end up doing that, you do need to know them. Remember, your test is next Thursday. So this one, first of all, there's kind of a mistake here. We should have told you that these were kites, or marked them accordingly. Otherwise, you can't really do it. So assume that these are the same, and then these are the same. Okay, so what we know here is we know that if a quadrilateral is a kite, so knowing that it's a kite, because I just marked it like a kite, opposite angles are congruent. One pair of opposite angles are congruent. So these two that I already marked are definitely not, or these two that are already marked are not congruent. So the 2 remaining ones have to be congruent. So what I'm going to do is I'm going to erase some of my markings. And then I'm going to call those X. And then just use the fact that it's quadrilateral so they all add to 360. So 85 plus 43 adds to 128. Take 360 minus 128. And you get 232. 232 remains for both of those angles. So like to get X, you have to divide 232 by 2. So those are both going to be 116. To make extra sure that you're right, you can always go back and make sure that they all add to 360. Then this one, similarly, we should have told you it was a kite, or marked it like that. So I'm going to tell you these are congruent. and these are congruent. And then from there, we should be able to find all those angles, but that's a lot of angles. Okay, so if it's a kite, the diagonals are congruent. So angle 4, or sorry, the diagonals are perpendicular. So angle 4 has got to be 90. All 4 of those angles right here have to be 90 in the middle. So this is 90. What else do we know about a kite? We know that the diagonals are perpendicular. I already used that. One pair of opposite angles are congruent, but only one pair. So we can use that. Okay, so after that, we know that there's a lot of triangle relationships going on here too. So to get angle 6 in this triangle, we know that those need to add to 180. So we can take 90 plus 73, and we get 163, which means that there's 17 degrees remaining for angle 6, because they all have to add to 180. So angle 6 has to be 17. Okay, then I have some other stuff going on here. Then these two like big triangles, if you think about it, these would be congruent by side, 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 because they share that middle side, and then they have two sets of congruent sides. So those red triangles are congruent. So therefore, if angle 6 is 17, angle 7 also has to be 17. Then I know that angle 1 is going to be 46 because this, okay, let me back up. This is 90. So then this also has to be 73. So angle 5 has to be 73. Because remember, those have to add to 180 in that smaller triangle. Then angle 1 is also going to be 46 because total it has to add to the whole thing. What do we have left? Angle 2 and angle 3. Okay, there's probably more than one way of getting these. But one way would just be to use how many degrees we have left over in this like triangle. So I know that this whole angle right here is 73 plus 46, which is 119. And I know that angle 7 is 17. So 119 plus 17 is 136, which means that this angle 3 must be 180 minus 136. So it must be 44. So angle 3 must be 44, which means angle 2 is also 44. Okay, I did not double check that at all, so it's certainly possible that I made a mistake. I'm sure if I did, someone will notice it, but that's what I'm thinking right now. I'm not going to look at it too closely, but we can talk about it more on Monday. This is just looking at the most specific name for each quadrilateral based on the given information. There's kind of like a little visual over here. Quadrilaterals, and then how you can break them down, splitting them up into different categories. And like the most specific ones are going to be on the bottom, and the most generic ones are on the top of this. It doesn't really like label their properties, so I don't know that it's super helpful, but we're kind of using it. So these are all quadrilaterals. We're trying to figure out if we can find anything more specific than that. So this one, to me, I know the diagonals bisect each other. It's hard to keep all these properties straight. If I were you, I might make like note cards or something, because there's been a lot of them. But diagonals bisecting each other is definitely a parallelogram. So I know that this is a parallelogram. It's nothing more specific than that, though, if that's all that's marked. So all I know is I know that it's a parallelogram. Okay, then this one would be a kite, because I have two sets of congruent sides. So that one should be a kite. This one, I know it's a trapezoid. Doesn't look like an isosceles trapezoid, because I see different numbers going on there. So this one is just a trapezoid. This one looks like nothing special. I see one bisected diagonal and a pair of opposite sides, but I don't think that's anything. So that should just be a quadrilateral. And then this one, I see one parallel and then one congruent that looks like an isosceles trapezoid. Because you have one set of parallel and then the legs are congruent. It doesn't look like a traditional trapezoid, but I think that's all we could say based on the diagram. Okay, looking back at this original one, I'm just trying to make sure I didn't miss something. Okay, hold on. These angles would be congruent because they're vertical, which means these triangles are congruent because of side angle side, which means that's congruent to that. Hold on. Then these angles are congruent because they're vertical, which means these triangles would be congruent because of side angle side. We don't know that those are all the same. Oh yeah, they're all congruent to each other. Okay. This one, you know what? I think we can call it a rhombus. I'll think about that a little bit more, but I think specifically that's got to be a rhombus because of triangle relationships. Okay, I'm done talking. That was kind of a lot. So it's possible that I made little mistakes on here. I honestly am not feeling very well, and I did not look at it super closely before I did it. But if I did, we'll talk about it at some point before the test. So thank you for watching. You're going to get your homework now, and it's a worksheet. On Monday, I will check your 7-4 worksheet and your 7-5 worksheet, and then I'll give you the quiz review for the group quiz on Tuesday. If you want to look at the review early, I'll have it loaded on Google Classroom probably this weekend, but Monday should be fine. Okay, see you Monday.